I was a little hesitant as an art historian to even talk about things I didn't know a whole lot about, like pigments. I was really inspired by the work that she did, in particular on studying craftsmen, artisans in the 15th century and the subsequent centuries. So Pamela, as you see, has been teaching at Columbia since the early years of the century. She studied in undergraduate work in Australia. She did her Ph.D. work at Johns Hopkins. And her books are really revelatory, I think, about the kind of work that she does. The first one was Business of Alchemy, in which what she tried to show is that the power over nature that alchemists have is really not just limited to them. It really is characteristic of a much larger society. And she explored all avenues of wealth and authority that would embrace. The painting, particularly that I have many kind of bent pages on, is the body of the artisan, artisanal craft, which is a study of artisanal craft and knowledge. That came out in 204s and big paperback. And soon to appear is From Lived Experience to the Written Word, Practice Encoded in Tech, which is about work she may be talking to us about now, which is how practice may have preceded the transcription or the recording of recipes in books, but and the way in which by working back through practice, we might be able to test the validity of those recipes that we find in early manuals of artistic practice. So Pamela, tell me if I'm wrong on all of this. Okay, thanks.
Yeah, sure. Yes, right. Yeah. Okay. Okay. Really, we should have had a conference entitled Art, Science, and Technology. I'm glad you're here. Otherwise, we would be lost. Well, I am going to try to not cut short, but be brief. Try to, maybe we can leave any discussion till the end and questions till the end. But can we, yes, let me just, I want to move this so that I tap, because sometimes my text is quite long. Can I scoot it over? Great, thank you. Well, thank you so much, Linda, and thank you, Herman, to Emily, to Roy, our savior, and to all the others who made this conference possible. I am extremely excited because at last I can talk to a biologist about lizard tails. So I'm very much looking forward to that because despite having talked about lizard tails myself for a long time, I have not actually had the opportunity to speak to a living biologist about it. So I'm really looking forward to that. So I want to start with this image, which is from Mary Terrell, the historian of science, Mary Terrell's Catching Nature in the Act. And what this is a description of René Réaumur, the 18th century natural historian and so-called entomologist, his experiments with frogs as he pursued perennial fascinating problems of generation. Was it spontaneous, caused by semina or seeds or something else? And in these experiments, he fitted these male frogs out with a little bodysuit, and he describes in great detail exactly how he did that. It took a lot of trial and error to do it, or not trial and error, but experimentation. Réaumur's interest in animal generation was part of a centuries, probably millennia long site of human engagement with nature around questions of generation, metamorphosis, and regeneration. The self-described new philosophers of the early Royal Society, right around its founding in 1660, studied these questions too, especially looking at putrefaction, generation, and regeneration intensively. For example, the mention that animals, the production of animals by the putrefaction of vegetables said to have been done by the Duke of Orleans, but the doctor knew of no such thing. An experiment of closing up blood and pieces of flesh to see whether it produces insects, experiment of producing maggots by cheese and sack, and so on and so forth. I love the one of the burning vipers and then seeing whether vipers can be produced out of that powder. Such investigation went on, not just in the new scientific societies in the late 17th century and Enlightenment academies in the 18th, such as with Réaumur, but had gone on in artists' workshops and probably in distilling and cheese-making rooms and kitchens since time immemorial. The history of modern science doesn't usually start in workshops and kitchens, but I will argue in this paper, as I have for most of my career, that in fact, art and science were the same endeavor before the mid-18th century. They emerged out of the same history of humans engaging with the beings and materials of nature, and they sparked material and philosophical investigations in the workshop, just as in the chambers of the Royal Society. Indeed, the history of artisanal workshops and the new empiricism of the Royal Society is a single history. It's not a separate history. The first collaborative, let me tell you why, the first collaborative publishing project of the Royal Society was to be what they called a history of trades. That is, they planned to interview all kinds of artists and artisans about their processes in order to write them down. They did this because they called themselves new philosophers. They wanted to upend university philosophy and teaching with their new method of experimentation and engaging and manipulating with nature, but they had no real idea of how to do it. And so they thought that by interviewing artisans, they would have information on how nature was transformed and manipulated. Their history of trades was unsuccessful, in part because the artisans were suspicious of their questioning, and in part because the fellows found the artisans quite uppity and insufferable in many cases. Evidence of this dynamic can be seen on this slide, which notes that Mr. Kroon is to procure from some fresh vipers and the operator to provide fresh hazel sticks. The operators, or artisans, pop up in the records of the Royal Society with great frequency, because the scholars who were the fellows of the society generally did not get their hands dirty, but instead had what one sociologist of science has called invisible technicians to undertake all the procuring, demonstrating, and experimenting for them. And you can be sure that Mr. Kroon had one of these operators actually procure the vipers for him as a medical physician, as a physician. He probably was in close contact with pharmacists who either had snake catchers catch them or caught them themselves. I'll return to snake catching at the end of my short paper today. Now I'll turn to some examples of the philosophizing, and this is an active verb. I say philosophizing intentionally, philosophizing about metamorphosis and generation that went on in European workshops in the 16th century. Okay, well, no surprise, you've already preceded me in this, Hermann. Joris Hufnagel, his exquisite studies of insects provide evidence of fascination with and close observation of processes of putrefaction and metamorphosis, and the kind of new life that was to spring out of putrefaction. And in his pursuit of naturalistic representation, but also of spiritual meditation, as Linda has made clear. Also in sculptures, such as here, where the Nuremberg master goldsmith Wenzel Jamnitzer represented 16th century, represented all kinds of insects and reptiles cast from life, which I'll explain in a minute, emerging from the slime of the grotto at the base of his sculpture. The whole sculpture is actually an ode to Mother Nature. So you have this grotto at the bottom out of which all kinds of insects and amphibians and reptiles are springing. Then you have the statue of Mother Nature here with this kind of verdant basin on top with little snakes cast from life. And then the whole thing is topped with this beautiful vase sculpture and then cast from life flowers at the very top. Jamnitzer also philosophized about metamorphosis and transformation in his depiction of the Greek nymph Daphne, whom Apollo fell in love with, pursued, sought repeatedly to rape, until Daphne called out to Gaia, the earth goddess, for help, who transformed her into a laurel tree, as we've already heard. And Jamnitzer has portrayed her transformation with red coral, her branches with red coral, a material of great interest itself, as something that transforms, as seen at the time, from plant into stone. Just to make clear that he is talking about metamorphosis in this sculpture, Jamnitzer has included generative stones at the base. Let's see. So you can see here these petrified worm casings. You can see this sulfur here and azurite, malachite there. Jamnitzer has included these generative stones at the base to show that he's talking about metamorphosis, because the petrified worm casings and the reactive sulfur, which, like this native silver, also people were very interested in native silver at the time, provided evidence of growth and transformation of metals and stones in the earth by nature itself. From these generative stones here at the base, the silver and gilding of the body of Daphne flow into these tiny cast from life leaves sprouting from the coral arms. And I think it's not insignificant that this is life cast leaves, and I'll come back to it, as I said, just in a few minutes. But let's give further examples of the evidence of investigation of metamorphosis and regeneration in the work of 17th century artists. Now, obviously, as Hermann pointed out, this is about imaging, this is about representing the world, but it's more than that. Art historians Karin Lehnhardt and Eric Joring have shown that Otto Marcius von Schreck, the artist here, kept reptiles and insects in order to study and to paint them, to represent them. The artist author, his contemporary Samuel from Hoogstraten, noted that when he visited von Schreck, he was, quote, amazed at the number of monstrous creatures he kept and fed, and how his thorough understanding of their nature was just as wondrous as his lifelike representations of their forms. Von Schriek's deep study and knowledge is confirmed by the natural historian and theologian Johannes Swammerdam, again, his contemporary, who, in saying that he heard from Otto Marcius that he had seen flies laying eggs in the bodies of caterpillars, which, as he said, I must own, I never saw this myself. That is, Swammerdam said in his dissection of insects. He said, I never saw this myself. He made clear that, like the members of the Royal Society, he relied upon the invisible technicians of artists, not just in representing, but also in observing and investigating nature. No artist was more involved in the work of investigating metamorphosis than Maria Sibylla Merian in her early work on silkworms and in her 1705 Metamorphosis of the Insects of Suriname. In the rest of this talk, I'll show that practitioners did not just observe and represent, nor did they simply take part in a philosophical discussion being pursued by the learned with their texts, but rather that the artists' workshops were in fact sites of investigation and experiment, both in the early modern sense of experiment as collecting together great numbers of experiences and writing descriptions or histories of them, like the history of trades, but also in today's sense of experiment that's used in modern science today. This is especially evident in the life casting of plants and animals, an art form very popular and widespread in the 16th and 17th century, but little known outside of art historians, outside of just a few people today. Life casts such as these that I've represented here, that are all from European museums, all 16th century, such as these were collected with great avidity by scholars, by notables, by courtiers at this time. And they were often collected together in what were known as chambers of art, or known in German as Kunstkammer. And this painting depicts a Kunstkammer, or chamber of art. These were combinations of natural and human-made materials and objects. So you can see some of them here. You see, of course, the natural shells. You see the representations of nature as well. You see the preserved objects. You see the porcelain, for example, a great source of interest at this time in Europe, and many experiments undertaken to try to produce it by transformation in the fire. You see the goldsmith's work and the jewels here, and so on. So this painting, and in fact, the name Kunstkammer really gives us a clue to the meaning of art, a chamber of art. It didn't mean a chamber of representation of nature or of other things. It meant a chamber of transformation, because art was in fact making with the human hand. It wasn't just representation, it wasn't just ornamentation or aesthetic purposes, as my two previous colleagues have made clear. But these kinds of collections, with their mix of art, of objects that were the result of the artifice of nature, and objects that were the result of the artifice of the human hand, were meant, in fact, to spark conversations on the relationship of these two kinds of art or artifice, and to compare the generative and transformative powers of nature to those of human art. So let's turn back to life casting. We're lucky enough to have a detailed account of the process of life casting contained in a remarkable 16th century manuscript that is full of descriptions of various trades, a kind of early version of what the Fellows of the Royal Society were trying to collect in their history of trades. And the way that you do life casting is that you take a living plant or animal, you kill, in the case of the animal, you kill it gently so that it doesn't have any lesions on it. that will be noticeable. And then you make a mold. You form the impression in plaster or some kind of molding material of the animal. And this lizard would have been done in a two-piece mold. You would then take out the lizard, or more likely you would burn it out. And then you pour metal into the mold. And what this drawing, this wonderful sketch on the right from the 16th century manuscript, it's showing how you should construct the mold. So the dotted line around here is the edge of the mold, and then, or the clay base that it's probably sitting on. And then these are all of the channels that you build with wax, which are then melted out. The wax runs out of this open gate in the plaster right here, and the animal is burned out. Then you open it up and blow out the ashes of the animal, of which there are not many left, actually. And then you pour the metal into this gate. It runs through the body of the animal. Then the air that has filled that body with the burning out is then vented out of these channels there. I just want to say one thing about this manuscript, which is now in the French National Library in Paris. It's a treasure trove for historians because it provides insights into making processes of art and daily life objects and into attitudes to nature. And this is an overview of the manuscript's contents, the categories, all of those different categories, 24 of them, I think, were compiled by the Making and Knowing Project. And this 340-page manuscript has 928 separate entries on various making processes, observations, recipes, all kinds of things. And this gives you a sense of the distribution of different kinds of subjects in it. And you can see that casting takes up, more than 30%, more than a third of this manuscript. And of that casting, the bulk of it is about life casting. The Making and Knowing Project, which I founded in 2014, published a digital critical edition of this manuscript available at that URL if you want to explore it later. And besides the full French transcription and English translation of this 340 pages, this edition also contains over 120 essays written mostly by students in laboratory seminars, which I'll explain what those were in a minute, including several essays on life casting. So if you want to know more about life casting, you'll get it. You can get it all here. This text of practice was probably compiled by a metal worker, perhaps with the intention of publishing the processes, but his project was never realized and it remained a chaotic compilation, but still contains much very acute observation and evidence of his firsthand experimentation, such as this. I'm just showing you this in order to show you the kind of entry that we have in this manuscript. This is about sand, that is the molding material that he's using. And he's trying all kinds of different materials in order to make a good molding material that will take an impression, a very fine impression. So I was fascinated by the manuscript. I began to read it, but it's so close to the practitioner's experience that it's actually impossible to understand it without actually working through the processes described. So I began to reconstruct its procedures, first in about 2007 with a silversmith at the Rijksmuseum, and then with students and team members of the Making and Knowing Project after 2014. Through these reconstructions, it became clear to me how deeply the author practitioner was engaged in investigating the behavior of living things, the things he was casting, as well as the behavior of natural materials in creating these works of art. Now I'm going to turn in just a moment to the kinds of investigations that we really came to realize. We came to realize what kind of knowledge he was making in this manuscript. But before I turn to showing you some examples of that, I'll just say that the research for these examples was carried out between 2014 and 2019 during the creation of this digital critical edition. And there were kind of 4 concurrent stages to this, but what I'm going to focus on here is the research that came out of the graduate lab seminars. And I want to say that the author practitioner's investigation as we teased it out, is not stated in explicit terms in the manuscript. I mean, this is the great kind of innovation of those 17th century Royal Society fellows, is that they figured out a way to write down experience. That was not something that was straightforward, and that continues actually to be a kind of ongoing challenge in modern science, but we really have a format now. The question might be how much to include of all of the methods and all of those kinds of things, but basically, there was no way of writing, or no accepted and way of writing, a kind of rhetoric of writing down experience in this period. So we had to tease it out through laboratory work. So it may not be initially exactly clear where I'm going with this. In our first year in the project, students repeatedly questioned where the quantities were in the manuscript, and they were trying to reconstruct these processes, these recipes, observations in the manuscript. There aren't quantities. They kept saying, where are the quantities? Where are the quantities? But they came instead to look for statements about the consistency of materials instead, like here, then apply a thick coat as thick as mustard or a little bit thicker. Consistency descriptions are an example of a sensory tool used in the embodied experience of the workshop. So here's an example of the kind of knowledge which you have to come to understand when you go into reconstructing this, when you go into trying to understand what kind of an investigation is art making at this time. An example of one such tool is what the lab came to call the squeeze test. And the squeeze test was this phrase here, which is important, repeated on several different folios, pages of the manuscript. The sand should give a nice hold, but still come apart easily. And what we came to understand as we thought about these sensory tools like the squeeze test was that these consistency statements were an important part of workshop investigation, because these qualitative statements were more important than quantitative measures in a world where materials do not arrive at the workshop in standardized form, and in which the workshop may well have been open to the weather. So this is a problem of dealing with the particularities of a situation. Much of modern science today is, of course, when it's not natural history or biology in most cases, but for example, the physicists' computer-generated trees is an attempt to reduce the particularity of nature. And this was a way to work with the particularity of nature. So this tool of consistency description provides more precision and rigor than quantitative measures would at this time. Another component of artisanal knowledge, what kind of knowledge is this knowledge of art, is the constant experimentation. The author practitioner repeats his trials constantly. Author practitioner is the term we gave to the person who wrote down and did all of these experiments. Casting accounts in the manuscript show the traces of constant experimentation, sometimes in the margin, a little note, try this. Any process of working with natural materials, especially non-standard ones, necessitates a great deal of experimentation. And this is not the unthinking or rote so-called trial and error, a phrase I kind of hate, but rather a process of trying, reflecting, extending the experiment, sometimes failing, which leads to new innovations, which I think any scientist would recognize this process of experimentation. Here, the students were reconstructing the scores of experiments in the manuscript for mixing sulfur, wax, and pigment to make a better modeling and molding material. In all of these processes of combining and transforming different materials, such as here, calcining, that is burning to a powder, oyster shells, bone, and alabaster, the author practitioner is constantly investigating the properties of these materials and how to transform them from one state to another. Hard, brittle oyster shells, for example, into the fine, powdery, impalpable powder. Throughout the text, he is preoccupied with the native properties of materials and their transformation. This focus is shared by many early modern practical writings, other kinds of recipes, for example, which instruct in how to transform materials into a more workable or useful form, such as transforming, very familiar, brittle iron into more malleable steel. This constant material investigation into transformation, which is common to any workshop, is a way to form hypotheses about what materials and processes work. And through this, to develop or to construct taxonomies of materials and standard ways of processing them. The constant work of experiment in transforming materials eventually reveals the underlying properties of these materials and assists in understanding relationships among them. From such experimentation, standard components emerge. Standard components such as technical terms. An example is this impalpable or impalpable in the original French, and it's a technical term used by metalworkers in French, Italian, and English at this time. And interestingly, the author practitioner actually gives us a definition of this technical term when he says, it is fine enough to slip through your fingers without being felt. So this is a technical term at this time, and there it is defined. Out of such intensive firsthand experimenting, systemic knowledge of natural materials also emerges, such as here in the system of categories used by the author practitioner and other metal workers. He uses the Aristotelian categories, cold, hot, wet, dry, to describe materials, but much more prevalent in the sand and the metal casting parts of this manuscript is an opposition between fat and lean, and sour and sweet, which form, and you can ask me at the end if there's time, exactly what these qualities are. These form a set of underlying principles that structure practices. If a sand is lean, for example, you need to make it into something fattier, something malleable, something that's clay-like. Okay, another part of practical investigation is imitation. This manuscript is full of processes of imitation by which materials are pushed beyond their native properties in order to take on or to imitate the characteristics and appearances of other substances. Here, gold-colored pigment imitates physical gold. Here is the gold, leaf gold, and then these are various experiments of the student to create an imitation according to this manuscript recipe of the color of gold without gold on silver. This is a commonly used varnish by furniture makers at this time to imitate gilding. So it's a common workshop practice. The manuscript contains instructions for imitation of all kinds: imitation marble, imitation glass, rouge clair, a kind of vitreous substance, all substances that can be found on extant objects from the period. The manuscript contains numerous imitations of expensive materials, but more importantly, I think, is the point that striving to imitate other substances by transforming materials helps to organize goals and processes in artisanal work. But imitation can also be about gaining knowledge of natural processes. The 16th century potter Bernard Palissy, also an author practitioner, claimed to imitate natural processes in the earth in his making of ceramics. So he saw his making of ceramics as actually giving insight about what happens in the earth. And particularly in his imitation of stones, such as jasper. These are glazed spoons on the right. Through such making, he developed theories about the ways that rocks and minerals are formed in the earth. So he saw his philosophy, his philosophizing about natural history and formation of minerals in the earth to be based on his experiments in ceramic. The manuscript also contains a recipe for imitation jasper, as well as imitation coral. I should just note that. But here is natural jasper, polished. Here's some natural jasper. And then here are some of the iterative experiments of the making and lowing lab in creating imitation jasper. Now, the author practitioner of this manuscript doesn't make the kinds of claims that Bernard Palissy does, but he's nevertheless engaged in the investigation and experimentation that underlies Palissy's method of making knowledge about the natural world. Another connection between imitating and knowledge making is in the manuscript's imitation of living things through the techniques of life casting. The author practitioner was preoccupied with imitating not just a stone, but imitating and preserving a life-likeness in the ephemeral living things. He did it by spectacular transformation of materials, not just the materials of the body of these organic beings, but also through the transformation of the sands through a quite lengthy process of experimentation, but then also calcining materials and mixing them to the right consistency and so on. The focus on the ephemeral was important. For example, insects. These are insects that obviously they present casting challenges. They're very tiny. They look big here, as Linda pointed out. This is a writing box in Vienna, and it has all kinds of life casts, but also some of those are not life cast at the top. But it has these spectacular insects, very, very tiny. That fly is tiny fly sized. And these casting challenges could only have been worked out through the many trials and much experimentation with molding materials. Lizards with their delicate limbs and fascinating tails and toes were also great casting challenges. Indeed, all those creatures that were of interest later to the Royal Society and to Réaumur were intriguing at this time to Yamnitzer and other life casters because they were creatures that were liminal between the elemental zones of earth, air, water, and fire. And that went through transformations, that is, lizard tails regenerated, insects, snakes, and other creatures seem to emerge from putrefaction and metamorphose through their lifetimes. Life casting was not only a place for practitioners to consider this elemental significance of such creatures, but also, as we have seen, involved them in much repeated investigation of earths and sands for making molds that would produce successful casts. I'm going to close with this idea of vernacular natural history. They also had to do much investigation of the behavior of animals and plants as they were being collected for life casting. This kind of investigation of animals and plants was the same that provided the experiential knowledge of so-called wise women who collected herbs for pharmacists and physicians in this period, or the root cutters on the right, who also provided roots and other herbs to pharmacists and physicians. These people knew what plants were efficacious, where to gather them, in what times of the year, and what ailments they treated. They were intermediaries between the material world and the textual knowledge of those university-trained physicians. But both parts of this broad network were essential in making knowledge about the natural world. So that's why I call it vernacular natural history. And in this manuscript, there are many instances of vernacular natural history, including observations and practices of catching, keeping, feeding, killing, then molding and arranging the animals for life casting. It's extremely unusual to have this kind of vernacular knowledge about these living beings codified in text or visual representations at this time. Okay, finally, I just want to offer one more example of the way that natural investigation is codified, not just in texts, but by the artisans in their material investigations and in the objects they made that I've just discussed. This is a typical Kunstkammer object because it displays, the nautilus shell displays nature's artifice, but the human artifice is demonstrated by this ornamental work surrounding this natural artifice. At the base are all of these little life cast grass snakes, all about the same size. And I'm going to just close by saying that the snake catcher, the vernacular knowledge of the snake catcher coming upon a brood nest of grass snakes is actually materialized in this base. It's codified here. Let me show you. Okay, let's hope this works. I forgot to try it out. Let's see. Nope. Yeah, here we go. Okay. Look at them. Go. Interest in these creatures continued up to the modern period, both in art, and this is a hamsa, which is a sign of good luck, made in Morocco with a lizard on it. Lizards and frogs were also used as birth amulets in both this period, but also much earlier. The interest in these creatures continued both in art and in science, especially lizards and their tails, and amphibians that emerge after freezing winters, like frogs, is still very much alive today, with literally thousands of scientific articles published on these topics in recent decades, many of them, I'm sure, coming from here, about which I believe we're going to hear much more, which is the big excitement of the day. So I'm just, before I close, I just want to acknowledge the core members of the Making and Knowing Project, one of whom is here, I'm happy to say, whom I had the privilege of working on this research in 2014 through 19. So thank you very much. Okay, we're now 20 minutes